Hi everyone, today we're going to be discussing the first FRQ of the 2018 AP Chemistry exam. This FRQ mainly discusses thermochemistry and calorimetry. In this question, we are simply asked for the oxidation state of chlorine in this sodium hypochlorite compound. We know that oxygen must have an oxidation number of -2, and since sodium is a cation, its oxidation state is the same number as its charge, which is +1. So to balance out this neutral compound, chlorine must also have a +1 oxidation state. This question is just some simple stoichiometry. We first multiply 0.100 liters by the molarity, 0.500 molar, to get the amount of moles we need, and then we convert from moles to grams by multiplying by the molar mass to get our answer, 7.90 grams of sodium thiosulfate. This is just final temperature minus initial. We see that the final temperature is around 32.5 degrees Celsius and the initial is around 20.0 degrees Celsius. So we subtract and we get 12.5 degrees Celsius temperature change. This is calorimetry, so we need to use our handy dandy equation Q equals mc delta T. The question gave us our mass, 15.2 grams. We multiply that by the specific heat capacity mentioned, 3.94 joules per grams times degrees Celsius. Finally, we multiply that by the temperature change we got in the previous answer, positive 12.5 degrees, to get our energy change as 749 joules. However, we're not done yet. The temperature increased in the environment, so that means the reaction has released energy into the environment. So we have to change the sign to negative. Our final answer, negative 749 joules. This question trips a lot of people up. While people just find the moles of sodium hypochlorite, we have to go a step further and find the overall moles of the reaction. But let's back up a little. To find our molar enthalpy, we need to take our energy change and divide it by the moles of reaction. Alright, when we convert from molarity to moles, we get 0.00250 moles of sodium hypochlorite. But we have to take this one step further and look at the reaction. For every 4 moles of hypochlorite that reacts, the reaction proceeds 1 time. So we have to divide this mole amount by 4 to get 0.000625 moles of reaction, meaning that the reaction happens that many times. Now, we can take the energy change we got before and divide it by this number to get our final molar enthalpy of reaction, negative 120 kilojoules per mole. You don't have to convert to kilojoules, but I think it makes the number look a little bit nicer. Remember that if the amount changes, so will the amount of moles. However, the overall ratio of moles to energy change will always stay the same. You must explain that because the student doubled the amounts of everything, the energy change doubled, but so did the reaction amount, so the molar enthalpy will remain the same, hence why it's called molar enthalpy, because it's per mole. This last question is an easy get. First, we look at the overall reaction and cancel our spectator ions, all of which are sodium. We already have the balance coefficients from the reactants and product side, so we just put in the ions. That's all I have for you guys today. I hope this video helped you with this FRQ, and I hope you guys will join me in the next video where we discuss the second FRQ from the 2018 AP Chemistry exam. Take care y'all, and I'll see you in the next one.